Hello everybody, Mingalaba. Welcome back from ClickTop Engineering Open Lecture Series. My name is Damien Tyke. I'm doing mechanics lecture series. And for those of you who are watching this video for the first time, we are covering the theories and most of the problem in Mechanics 2 student book by Pearson Edexcel International A Level, right? So we are covering all the problems, most of the problems and theories from this textbook. So please subscribe our channel. At the end of this lecture series, you would be able to sit A-level exam, of course, if you closely follow with our lecture videos. And this time we'll look at the two things in this video. The first one is the equation to link the final speed, initial speed, and the total distance traveled for the constant acceleration motion. And we were also trying to apply this in solving some of the problems in the textbook. So basically we are doing these two things, right? And now let me just straight away start with the finding or getting the formula for linking the final speed, initial speed, and the total distance traveled, right? So we will look at the constant acceleration motion again, and of course, if you recall, the final speed at time t equals to just initial speed u plus at, and apart from that, if we are interested in finding out the average speed, of course, our average speed at any time t can be formed by the speed at the time plus initial velocity divided by 2. So this we call the average speed of the particle, right? So if you look at the particle motion diagram, we have the particle at time t is equal to 0 at the origin here, and then initial velocity time t is equal to 0 is u, and then the object accelerates with constant acceleration a, and because it is accelerating, the direction of the velocity and the direction of acceleration are just the same. And of course at time t you have the speed v, and now you have the equation for linking the speed at time t, which is just equals to initial speed plus a and t, right? And now we are interested in finding the total distance traveled. So how much is the total distance traveled, which is just described by us by the particle. And now if we want to find the total distance traveled, all we need to do is just find the area under the VT graph. So we were trying to look at how we can get this, right? And now for some of you who may wonder why we have to find the area under the graph if we want to find the total distance. So in order to see that, let's just look at with the constant speed motion, right? So if you look at the speed time graph or velocity time graph for the constant speed motion, because the speed is constant, it will be just a horizontal line, meaning that the speed at any time t is just constant. And now of course for constant speed, the speed of velocity is just displacement or the distance divided by time. And now the total distance from this equation you can just manipulate and you will get the total distance, which is just s is equals to v times t, right? And now if you look at the expression for the total distance, which is just v times t, so if you look at this carefully, v is the height of this rectangle and t is the time taken, which is the width of the rectangle. So what does it mean? It means that the total distance is just area under the speed time graph. So all you need to do is you just have to find the area under the speed time graph. So as I highlighted in the green color here, right? So from this we can conclude that if you want to find total distance of the particle in any motion, all you need to do is just find the area under the speed time graph. And of course this we can apply to our constant acceleration problem. So let's get back to here. So basically we want to find the relationship between final speed v initial speed u and the total distance traveled. And in order to do that, we can start with the expression for total distance. So the total distance, just based on our observation, it just equals to area under the speed time graph. So let's try to do it. So if you look at the constant speed motion, the speed time graph for constant speed motion, you can see here initial velocity is u and final velocity is v. And of course, because it's constant speed, the slope is a constant. It is a straight line. And now if we want to find the total distance traveled between from 1 second, from 0 second to any time t second, all you need to do is just trying to find the area under the speed time graph. So if you look at this area, is a kind of trapezium. And now for the sake of simplicity, we were trying to just look at this in two split area. So the first one is the area of this rectangle. So we just split this into two regions. The first region just a rectangle, and the second region just a triangle. So all you need to do is just find the area of the rectangle below, and then area of the triangle there, and then you just sum the two area, you will get area under the VT graph, right? So and let's try to look at this. And now if you look at this, for the area of the rectangle is very straightforward because the height is u, the base is t, so its area will be just ut. And now if you look at the triangle, all we need to do is just find the height. So the height, if you look at this, it's just v minus u. From the graph you can see easily. So the height of the rectangle is v minus u, the base is just t, and since it is the rectangle, the area can be found by half times v minus u times t. So half time base and height, so base is t, height is v minus u. So for that reason, the total distance is just ut plus half times v minus u times t. And let's just try to expand the expression in the second term. So you have ut plus half vt minus half ut. And now if you look at this, ut minus half ut is just half ut, and now you will have half ut plus half vt. And now we're trying to take the common factor, which is just half and t. So your total distance traveled, in fact, is just half times v plus u times t, right? And now here, before we move forward, if you look at this expression for the total distance, it's just half time v plus u times t. So if you look at this, half time v plus u is just in fact the average speed of your particle, and for that reason, in fact, we can say that the total distance traveled can also be formed by the average speed times t, right? So total distance traveled can be formed by v bar t, and of course v bar t is just v plus u divided by 2, right? So now let's go ahead. So don't forget, our primary purpose is we want to link the total distance traveled with two speed without having the time expression. So we have to get rid of t from this equation, and of course you can easily do that because for constant acceleration is equal to just v minus u divided by t, right? And now of course if you want to get rid of t, you can use this equation. So t will be just v minus u by a. So what we do is, in place of t here, we will just substitute with v minus u by a. So you are getting rid of t from the expression. And now your total distance is just half times v plus u times v minus u divided by a. And now of course v plus u times v minus u is just v squared minus u squared. So this is the identity from the linear algebra. So you have s is equal to half times v squared minus u squared divided by a. And of course half and a going to the other side, you have 2as equals to v squared minus u squared, and then v squared equals to u squared plus 2as, right? And this is in fact the equation that we are trying to derive. So this equation shows the relationship between final speed, initial speed, and acceleration and total distance without knowing the time. So the advantage of this equation is, even we don't know the time, we still can find the total distance traveled if you know the two speed and acceleration. Or if you know the initial speed, the acceleration and total distance, you can find the velocity information without having the time, right? So in fact, if you can recall our previous video, the object was freely thrown vertically upwards and then it's fall back. But after it passes the initial height, if you look at the free falling motion after passing the initial height, you don't have both the information of the time and the speed. So in that case, if you use normal velocity or speed equation, you cannot get the speed, and you have to relate the two speed with the total distance traveled. So which is exactly the purpose of this equation. Without knowing the time, you can just relate the final speed, initial speed, the constant acceleration, and the total distance traveled, right? So I think that's good. And now, before we look at the numeric problem, let's just try to see some of the important points again. So constant acceleration motion, of course, the final speed v is equal to u plus at, and the average speed v bar equals to v plus u over t. And now your distance traveled can be found by having the area under the graph. So we just basically found the area of the rectangle and the area of the triangle here, right? And of course, from that, what we have is s is equal to half into v plus u times t, or s is equal to average speed v bar times t, and finally we get v squared is equal to u squared plus 2as. So now let's try and look at the numeric problem. All right, now let's just look with a numeric example. So you can see one of the problem in prior knowledge check for chapter 1 in the textbook on further mechanics 2, the one that we are using. So if you look at this problem, a small ball is projected vertically upwards from a point P with speed 15 meters per second, and of course you know it's just freely thrown against the gravity. The motion is vertically upwards. The initial speed is 15 meters per second. And the ball is modeled as a particle moving freely under gravity. So freely means the air resistance can be neglected. And find A, the maximum height of the ball, B, the time taken for the ball to return to P. So what you need to find is the maximum height and the time taken for the ball when it returns to P. So of course, if you look at A, at the maximum height, based on our theoretical knowledge, we know that the speed will be 0. And if you look at the strategy, we have just derived the equation linking the finite initial speed and the constant acceleration and the distance. So in this case, maximum height is just the distance traveled from the initial position to the maximum height. And we know both initial speed, which is 50 meters per second, and the final speed at the maximum height is 0. And of course, for freely throw upwards vertically, the deceleration will be just minus 9.8 meters per second. So we know uv and a, that we can easily find the s. And if you look at b, if we have to find the time taken for the particle after it falls back and it passes through point p again, we don't have to find the whole journey, just find the first half of the journey, and then we just multiply by 2, right? Okay, so now let's try and look at with the workup. So just wait a while. All right, so just wait a while. I don't know what is the problem with the ink. Sometimes that happens, so I'm sorry about that. Okay, so now let's try to look at the solution. Right, so if you look at this, your ball is initially a certain height and the initial speed is 15 meters per second at position P, and then the ball is released vertically upwards, and of course when it's get maximum height, the final velocity will be 0, and you are asked to find the maximum height, which is just the total distance traveled from point P to the maximum height, right? So, and of course this is the constant deceleration motion, and the acceleration value is minus 9.8 meters per second. So let's try to look at that. Again, the given parameters are u is equal to 15 meters per second, and the parameters that you need to find is a, maximum height, b, total time. And let's try to look at the solution. Um, you know the motion is constant acceleration, so acceleration equal to minus 9.8 meters per second square. And of course, that's the maximum height. The speed is 0. And as I have explained earlier, you have the relationship between speed, initial speed, the acceleration, and the total distance traveled. So in this case, is just v square equals u square plus 2 times a times s. And of course, the final speed is 0, and the initial speed is 15, and the acceleration is minus 9.8. So 2 times minus 9.8 s, going to the left-hand side of the equation, it will become positive. So 2 times 9.8 times s equal to 15 square, which is just 225. So the distance traveled s will be just 225 divided by 2 times 9.8, and your answer is 11.5 meter. Right. And now for the second part, you want to find the total time taken when the ball again returns to position P. So this is the whole journey from initial position to the maximum height, then the maximum height to free fall to the position P again. So of course, as we know the theory, we just have to find one half of the journey, and then the time taken for one half of the journey, and then you can just multiply with 2, because just 2 times the time taken for the first half of the journey. So we were trying to find from position 1 to position 2, which is just freely throw upwards motion. So t12 will be just v minus u divided by a. That one, of course, based on the constant acceleration formula. So final speed is 0, initial speed is 15, your acceleration is minus 9.8. So you will get 0 minus 15 divided by minus 9.8. And of course, you have the two negative numbers. So you have the sign will just cancel, and you will get 15 divided by 9.8. And now the total time taken is just 2 times the time taken from 1 to 2, which is just 2 times 15 by 9.8, and you will get the answer 3.1 meters per second. Right. So now you have just applied your theoretical knowledge to solve the problem. So the theory that we learned today is just the relationship between the initial speed, the final speed, and the total distance traveled. And of course, we have just applying to solve this particular problem. So if you know the initial speed, the final speed, and the acceleration, you can easily find the distance traveled. And for the combination of freely throw upwards and free fall motion, if we want to find the time taken, you just find the time taken for the first or second half, and then you just multiply with 2. Right. So this is the numerical problem that we looked today, and in the next video we will have a practical demonstration of this kind of motion. So subscribe to our channel, and of course study the previous lessons. So with that, let's just say goodbye here. Hello, bye bye.